Okay, I think we can start. So hello everybody to this second webinar. First webinar was yesterday by Professor Kongduk. So he introduced most of the IoT technology and especially the hardware parts, the radio parts, and some of the communications. So in this webinar, we'll go more over the APIs parts and the web applications. But first, I wanted to go over the technology from end to end. And I will show you also a simulator, because I know that everybody is at home. I am at home also. And we might not have all the hardware right now in our hands, or we are not able to go outside to deploy any hardware. So I show you that simulator. Okay, so the course material is on our website, waziup.io, right? So I invite you to open this website, and all the resources will be there. I will also copy the links as we go. All right. So don't hesitate to interrupt me if there are any problems or you have questions. And we'll take also questions at the end of the presentation. Okay, so let's start with our overview. So basically, this is our technology. So it's a three-tier architecture, and there are those three elements: the Wazidev, the Wazigate, and the Wazicloud. So Wazigate, as Kongduk was saying yesterday, is a LoRa device. So this LoRa is this new radio communication, long range, low power, low cost, and low bandwidth. So you transmit very less amount of data through LoRa. So you have one Wazigate that can cover several kilometers around, and that can cover many Wazidev, any kind of device, actually not only Wazidev. So up to 200. So let's start with the Wazidev, and it is here. I have it on my desktop. I hope you can see it. So this is the Wazidev. So you can see it's based on Arduino, and on the other side there is a LoRa chip, and this part here is in an antenna, a LoRa antenna. So Kongduk was explaining all the characteristics of this board. Today I just want to show you how to use it very quickly. So the idea that you plug it on the pin boards here. You plug a sensor. I don't have many sensors at home. They are in my office, which is closed now. But I found this one. So it's a gas sensor for a CO, right? And I can plug it in the right place on my board, like that. And I'm ready to go, right? So this is the simplest circuit possible I can do with one sensor, right? And now comes the time to flash it. So I hope many of you already know how to flash an Arduino device. It's very simple. So let me show you now. I connect it with the cable, a USB cable connected directly to my PC. And I start, so this is an example, the wiring diagram here. And I fire my Arduino IDE, which is here. Previously, I have loaded the Wazidev library in my Arduino IDE. So for that, all the instructions are given on our website. So our website is waziup.io. You can find it easily on Google. And there is a user manual for Wazidev. So here, it explains you everything you need to know, how to install the Arduino IDE, how to load the libraries in, and how to flash. So let's try. So from my Arduino IDE, I select any of the sketchbooks proposed. So there are several of them. So for example, LoRa temperature, or LoRa soil humidity. All right, this is the one. And it's a very simple program. So the idea that my sensor is connected on one pin, so I mentioned that pin here. Then I instantiate my Wazidev library, which will manage everything for me, including LoRa. I mentioned the name of my sensor, the channel, and I call the setup. So Arduino works with two functions. One is called setup and one is called loop. So setup is executed at the beginning, and then the loop is executed repeatedly. Next step is to read one of the pin to collect the value, right? And this value is here and will be sent like that through the LoRa, right? And I name my sensor to this soil humidity. I name it SM1. All right. I don't have a sensor humidity right now, so I would just put a fixed value, 15, like that. And I click on the upload. It's uploading right now. Done. All right, so now I can open the serial monitor just to verify. It is starting the LoRa. You can see the chip is detected, set, calibrated, and we start sending values. So this is a 15 I wanted to send, and it has been sent, right? All right, so that was super simple. That's the first step of the end-to-end chain I wanted to show you. The second step is the gateway. So coming back, this is the Wazigate here. So I have an example here that is set up also on my desk. Right, I hope you can see it. So it's a gateway, and it is based on Raspberry Pi. So this is a really common Raspberry Pi here. It's very low cost, but it's a full computer, right? With the difference of the Wazidev. Wazidev is not full computer. It's a microcontroller, right? But this has a really full-blown microprocessor, and it has a hat on top, right? So this hat, we call it the Wazi hat. It is also equipped with our LoRa chip. It has an antenna, which is not plugged right now. And additionally, some new models, like on this picture, have a little screen to know what's going on inside the Wazigate. So this Wazigate has an interface. So let me open the interface for my own that I have on my desktop right now. So when it is connected to your PC, you can connect directly to it using a special address called wazigate.local. Here I am connected to this Wazigate by Wi-Fi, and I'll put the admin password, and I arrive on this interface, which is the interface of the Wazigate. So it's like your router at home, so you have to make some basic configurations, super simple. Basically, you have to give it some Wi-Fi configuration. So this is my Wi-Fi here, and some credentials to access the cloud, and that's it, right? So now the Wazigate is configured, and I will check on the cloud. So cloud is the third part of our setup. So it's a 3-tier setup. So first tier is the Wazidev. We did it already, so we programmed it, basically. Second tier is the Wazigate. We also set it up. And I remind that on the website, you have all the instructions. So you go to user manuals, Wazigate. And here you have all the instructions to build your own, basically, and then flash the ISO image. The images are available on the download section. So we just published the version 1.1 version for the Wazigate. I think is open source, so it's also available on GitHub. Right, and now Wazigate is running and is receiving our data. Let's check that. So I go on the interface of the Wazigate. I check in the logs. And I can see that some data is received. Wow, that's my data here. So it was called SM1, and the value, fixed value is 15, right? So this Wazigate is recollecting the data of LoRa here and sending it to the cloud. So it's time to open the cloud. So there is a button here, it's called Go to Dashboard. And you can create, also right now, you can do it. You can create an account there, also with Google. You log in. And let's see my gateway. So if it's correctly configured, it should appear under you. I have several gateways. This is the one which is active. You can see now. So it is here. And this is my device. So this is my gateway. This is my device. It's called my device 2. Right? And this is the same I put in the code. Okay, its name is here. My device 2. And that's also what I see here, my device 2. I go inside and I can see that I was setting SM1, so it was soil moisture, if you remember. The value is 15. I can check in and see that it was constantly inputting 15 value. So now let me take you through the various features of the dashboard, and we'll see how to create an application based on this dashboard. So, so this is the sensor value. You can do different edits on the sensor. You can also try yourself. You can calibrate it because sensors need most of the time calibration. For example, the sensor value here is a raw value. It says 15. But soil moisture especially deliver values usually between 0 and 1000. But what you're interested in is a percentage of humidity. So you need to calibrate that. And maybe the value 300 will be 0%, the value 900 will be 100% of humidity. So with this button here, you can do different experiments to obtain the real value based on the sensor value. Just as an example, for soil moistures, you have to collect some piece of the soil that you are interested in, and the procedure is to put it in the microwave. So you microwave your soil and you dry it up completely. So that is, you remove all trace of humidity from the soil. Then you put your sensor in and you say this is a 0% value. So you take the measurement and you say that this value here that I measure for the dry soil is 0%. Then you do the same with another data point. For example, the maximum humidity, 100%, could be with the soil completely soaked wet. So you do that, you put the water in soil, and you do your measurements. You get the value from the sensor, and you do the equivalent. So and then the dashboard will do a simple linear regression between those two values and display the correct value here, right? Here you can get the data. Definitely you can download it. So this is your data row, and we'll see in the API a bit later in this presentation how to do that programmatically. Another feature interesting is the direct connection to the gateway. So this is my gateway here, and on clicking on remote access, you access to your gateway. So this gateway might be remote, it might be in the field, and I can access it and configure it and maintenance it from remote. Another feature which is completely new is the geolocalization. So this is my device here. There is two new features here. One is the location, and one is the device QR code. So the idea is that I know some of you are using already the Wazigate and this website, so you might be interested. So the idea is to download this QR code. Here you have it. You print it. You stick it on your device, right? And then I will use my mobile phone and say I'm going in the wild, I am going in the field, and I want to recognize a sensor and to know what's going on with this sensor. So I start my QR scanner, and I will scan this sensor here. So it is on my screen, so right above the webcam, and it found the device, right, with my scanner. It's a normal scanner. I click on the link provided, and opening here is I log in. Here is my sensor. So if I go in the field, I scan my sensor, and I get the status of the sensor with the last values of that sensor. So it's also working on the mobile phone. Next stop is to geolocalize this sensor. So let me show you that here. So say you are still in the field, and with your mobile phone, this is a map here. The location is wrong. So you click on change, then get the location, right? And you notice the map has just changed because we are using the GPS from the phone. And I am located in Verona, in Italy, so the position is now correct. I validate. And now I can refresh also this page. I will see here the new location has been just updated for this sensor. It works also for gateways. So if you have a fleet of different sensors deployed in the field or in an industry or on cattle anyway, you can use the location from your phone. You can locate either sensors or gateways. It works also on the gateways. So same procedure, you have different gateways, and you can change it, use your location from your mobile phone or even from your PC, and update it. And you can print this sensor tag. This tag basically contains the address of the device that you see here. Another feature is the notifications. So basically, my sensor that we created before, if you remember this one, that is now sending data, the value 15, I can create a notification. So I click on add notification. And here the work you have to do, you have to enter two things. So the first is a condition and an action. So for this sensor here, my condition is the following. So first I select my device. Okay, it is already pre-selected, but there are many others. And in a device, so this is my device here, right? On top of this device, I have sensors, right? So this is the hierarchy we have. So this device contains sensors, and this is my sensor here. So I select one of my sensors. There are two possible sensors on this device. And then I create an expression. Very simply, I want that something happens if the soil moisture with covalence M1 is more than 30%. What will happen? A message will be sent. You write down this message here. Some part of the message can be variable. So for example, this tag here means please pass in the value of the SM1. SM1 will be 15, so that means you will receive a message with written value is 15. And you select a number of users and a number of channels to it SMS voice. All right, so you can try this also. Of course, you have to set up your profile to receive those messages. So you have to set up your phone number and a Twitter account. All right, so you can create projects, which is a summary of your sensors and devices. This is an example with Paul here, and there is a GPS location here that he is using in his application. And the position and the different in Nairobi, and the different values are under.
Yes, sir.
Hi.
Hello. Yeah, I want to know if you add a notification.
Yeah.
How it connect to your mobile phone? Do you use a GSM module, or it's between the operator and the cloud service, or how it works? Like.
Yeah. Good question. So this notification. So as you understand, we are in this stage, right, in the cloud now. So that means that a device make a measurement on one of its sensors connected by wires. The value is sent over LoRa. So this is remote connection, several kilometers between the device and the gateway. Then the gateway forwards it to the cloud via a normal internet connection that can be Wi-Fi, cable, 3G, and it arrives in the cloud. Right, and now we are in the cloud, so we can do whatever we want. So the cloud, you set up the notification in the cloud in this dashboard here, and this platform is using some SMS provider for SMS, right? So it will use the SMS provider to send the SMS, and then this SMS provider is having some technology to send the SMS to you via the GSM network. All right, so we saw the dashboard, and this is already our first step. When you set up your IoT devices and IoT gateway, you can have it on the dashboard at the display and program some actions, manage the gateway from a distance, right? And I wanted to show you some of the use cases that we developed already some time ago. So in agriculture mainly. So those devices are well adapted for agriculture because they are low cost and they are long range. They don't consume a lot of batteries. So for example, here, this is a soil moisture that we developed. So it's just a small box like this containing the Wazidev with an antenna and a wire that goes in the ground, which is the soil moisture, and it is transmitting the data. So as Kongduk was saying yesterday, if you send data, it's a very small amount of data, right? Basically, we are using this LoRa network. The frames in LoRa network, they are around 200 bytes. So 200 bytes is very small. It's an SMS, for example, 200 characters. So you will not stream a video, but for measurements in the ground, it's enough. Another example here is fish farming. So that are devices for fish, also very low cost. There is a solar panel, so that might also answer your question here, mounted on top for power. And it is equipped with different sensors. So there is a oxygen sensor, dissolved oxygen, a pH sensor, and a temperature sensor. So as you know, the fish are breathing, right, in the water, and they're breathing the oxygen, which is dissolved. However, if the oxygen comes missing, the fish will start dying. So, and then for the farmer, it's very difficult to see if the oxygen is missing or not. they cannot see it. So we need to measure it. And with that, we notice that the amount of oxygen goes very low at night in the fish pond. So this is a fish pond here. It goes low at night because during the day there is some algae on top, and it does the photosynthesis, and the oxygen is replenished in the water. But at night, the fish is consuming the oxygen, and at the end of the night, they start dying because the oxygen is missing. So this device here can send you to some alerts with an SMS, as we see. So as I explained, the SMS is not sent directly by this device here. The device is sending the data through LoRa to a gateway which is mounted on the rooftop of the farm. And then this gateway has access to internet. It sends the data to internet, and then we can manage from here. So it is not equipped with the GSM shield, for example. Mm-hmm. It's just LoRa. All right, so another example is the cattle rustling. So it's also, this is a DIY cattle collar, which is mounted on the cattle, and there is a wire around the neck of the cattle. If you break this wire, then it is anti-theft, right? So it will send you a signal. Actually, it's just sending periodically a signal, even if the device is getting broken. You will know it because you will stop receiving signals, basically. So here also the reliability is a big problem because it's a really rough environment, right? So the cattle will go against the tree, and maybe after some time it will break down. So further versions are more integrated actually than this one. And then there is a small GPS inside, and they can locate your cattle.
It's GPS.
Yeah, this one is GPS. It's a pity Kongduk is not listening because he was realizing this one. Okay, so there are many more examples. We'll also update them on the website little by little. For example, Paul Emison, which is here, has developed a personal locator. So it's a device, you correct me, Paul, if I am wrong, a device based on Waziup for people that get lost in the wild, basically. So if you plan on a trip of hiking, you can wear this device. It's a very small device. It's a wristband, actually. And it will send signals, and your GPS position will be sent through LoRa periodically. All right, another. So this is an application, actually not an application, it's a competition we made about data analysis. So using our devices on soil, those devices here, we deployed them in several places, in Senegal, in different farms, and in Ghana. So this is Ghana here. And we collected this data from 3 months. And with all this data, we started a competition, a data science, machine learning competition. So you can check out this website here. Right. So this is basically the idea that we collected all this data and we provided it to the scientists. It's a soil moisture data, basically. And we asked the scientists, okay, you have the soil moisture for the last 3 months. We provide also some weather information, like the temperature of that day, if it rained or not. And we asked them, now for the foreseeable future, that is 5 more days, can you predict the soil moisture, right? And that was the result. So basically, you understand this is a sort of like weather prediction, but for the ground. So we provided a long shot of data. Let me show you this example. So for example, this is what we provided for one plot. There was 4 plots, and you can see the humidity during time that was measured by our sensor. Of course, the calibration first point is wrong because it goes below 0. So it should be recalibrated. And there are several steps to clean the data and normalize it, resample it. Okay, those are all things that you do in machine learning. So this would be another lesson. And the data stops, and you ask them, can you predict the data for the next 5 days, right? So actually, we provide to the scientists only past data, but we have also the future of the data. You can say it's not really future, but for them, we say it's future. So we provide, this is called the training set, and we keep for us 5 more days. They don't know it, we know it. It's called the validation set, right? And they do the prediction. And the winner, this is the outcome from the winner. So there are 4 plots that we wanted to test. There are 2 curves. So one is the ground truth. This is really what happened at that moment and as measured by the sensor. And the other one is the prediction he provided. So you can see that prediction is quite good. It's very close to the reality, actually. The algorithm he used is called XGBoost, and using Python libraries. So in another webinar, if you have the occasion, we'll come back on machine learning. So this is just an example also of how you can use. So this data was extracted from the Waziup platform. I will show you how. And then there was 700 participants to this challenge. And they was ranked by how close they are from the prediction from the reality, right? Because we have the reality, so we can compare it. So there is just this distance between the 2 curves. There is a formula to calculate it and provide a score for that participant. Let's go for the APIs. So now we are going back a bit toward the applications. So there are basically two main protocols for IoT, and one is a good old HTTP, and a newer one is MQTT. So, and they are really complementary. So, because they are supporting the different models, so you can choose one or the other, basically. So HTTP is a request response model. So basically, in this model, you make a request, you get your response. So you request from a server, it give you a response, and after that, it forgets about you. So this is what we do with the GET. And even if you don't know APIs, I bet you that you use the GET every day when you are going on the internet. For example, this website here, I using my browser. And when I want to, I enter a URL here, and I type enter, and behind the scene, my browser is doing a GET for me. So let's open the network. You can see the GET method is GET here. But there are several other methods for HTTP. Post, put, and delete. You can also do a post, which means send some data, basically. Put means modify this data, and delete means delete this resource, basically. That's the HTTP request response model. It's relatively simple. But there is a problem with this, this model here for IoT. And the problem is that my sensor might have a lot of new values, right? It might create new values every 10 seconds. So if I have an application, so say your application here wants to display the sensor value. If you are using HTTP to do that, that means you will get the value once, right? But after 10 seconds, you want to know if there is an update. So you do a get again, and again, and again, right? So every 10 seconds, you have to do a new get, even if the data even didn't change. So it's not a very good protocol. It's called polling. Polling means regularly checking for the data if there is something new. A better way should be to do what we call an inversion of control. That is, instead of getting the data from the server, you say to the server, please update me. This is me, right? And now please update me if there is any novelty on this sensor. I am interested in this sensor. Please wake me up if there is anything new. So there are three verbs. The most important one is connect. It's a connected protocol, right? It's not like HTTP. With MQTT, you are permanently connected. So you start the connect, and then the server knows you and communicates with you. Then, as Kongdu was saying yesterday, you publish and you subscribe. So publish means that you want to push a new information on the server, and they are categorized by topics. And you can also subscribe on one topic and be waken up if there is any novelty on this topic, right? So let's start with the REST HTTP. So this tutorial, you find it in user manuals, API reference V2. And let's try right now, right? So how to get the value of one sensor. So in the list, I can go to read data points, for example, or let's read directly a device. So it's using the curl command. So if you don't have it on your PC, you should install it. It's explained in the beginning of the tutorial. It's a command line. And let's try it right now. After I will explain the different parts of this command. So I copy paste this command, I execute, and I get a bunch of data back. This is my data here. It's not really readable. It's JSON actually. So I pipe it into a tool that you need to install also. It's called JQ. And I have this nice representation. So here I just made the GET request, right? So this is GET. And I give a URL that you are accustomed with. So in this URL, there are the different parts. So the protocol, the domain, and the path. And the path, on the path, I asked for one device. It's called my device, right? And I get the device in the JSON format, and there is all the details, right, on that device with the values even. So some values are here. Values is here. This is an array of values. They are the same that you see on this dashboard. This is exactly the same. Right, so here this is displayed on the dashboard, and in the background, this dashboard is also making REST API requests. This is a REST GET request, right, on my device. So it's exactly the same. So, and it is getting back a JSON. Okay, this is a JSON I got back in my application browser. I will show you a bit later how this application is made also. All right, so this is my JSON here. So, sorry, I closed it. Using my command line, I can also retrieve and talk with the server. The full API of Waziup, so is available on this URL here, api.waziup.io. And there is an interface to interact with all the API endpoints, including the devices, the sensors, the values, so you can exploit and understand how it works. So let's do again the same thing. So try to see a device. So I remember my device is called my device too. I put it in this field called device ID, execute, and I get the response here in terms of JSON. So this is the details basically on my device. My device contains different information like the gateway ID, its location, its owner name. It has some sensors attached on top with the value. And here it is explained, it is giving you also the same curl command that I was doing before. So I can also copy paste this one and retry it. Right, I get again the JSON, the full JSON, right? With this protocol, so the REST protocol, this was the GET, right? But I can also push. I can also use the term put or post, as we just saw. So let's try it. So from the tutorial, there is given how to push data to your sensor. Let's do it with curl, and after that I will show you how you do that in your web application. I curl post, right? This is a post here, and I give a full path for my device /sensors, the name of the sensors /values. So this is the full path of the REST API. Then I provide another thing is called a header. -H is for headers. Here what I am saying is that the data, this is the data here I want to push. I want to push a JSON type of data, right? So I'm saying to my server that the data that is coming here is also written in JSON and not plain text or XML. So here I have the interface for the post also, and I can post something on my device too. TC1 and some random value. Execute, right? And it gives back a code. I'll show you what do they mean. So this one is the curl command. Let's retry it. Maybe I was making some mistake before. Okay, it has the same structure. So it has a post here. This is the verb, a method post. And the full URL, including the resource I want to update. The header, because I am including here two headers. Sorry. First header is, okay, the content type I was talking before also. I am telling to my server the data that is here is JSON, right? So I say my content type is JSON. I'm also telling something else. I'm telling that accept, that means if the server wants to send me back something, please send it to me in JSON format also. Because maybe the server wants to reply in, also can reply in XML, but I'm not interested in that. I'm interested only in JSON. So JSON, the way in, JSON, the way back. Let's try it. Okay, it was accepted. And now I can open again the dashboard and check that out. All right, 25. So that's what we just sent. Okay. So this one, I show you the two verbs out of 4. There is get, post, put, and delete. They are also used, and from the tutorial, they are shown. For example, delete your device here. So you can go through, okay, it works basically the same. And put, if you have something already existing, it will put it there. So this is a summary of the REST mechanisms, right? So it is based on HTTP, which is very well known for transferring HTML. So HTML is a description language for web pages. It is HTML basically is a document, and HTTP is the transfer protocol, hypertext transfer protocol. So you make the request, you get the response, and then the server will forget about you. Those are the methods, and they are relatively similar to the CRUD operations. Not exactly similar, there are some difference, but relatively similar. All right, and this is a response code. So when you are talking to an HTTP server, so let me show you, for example, we made a GET before, and I want to show you some details. So here I made a GET, right? So this is the data I got back from my GET. But during the transmission, many things happen, and this is described here. So first of all, I use the HTTPS protocol. S stands for SSL, basically. It's an encryption mechanism, relatively complex, with keys and certificates. So this is the handshakes between the client and the server. They will verify that I am me, and they will encrypt this message, and I will decrypt it and display it here. Right? And there is also many things that goes in the header. So this is let's say a section of the message that comes back to me. So you can see host, user agent, accept. All this is part of the header. You can see it's quite long, right? And this is why HTTP is not also very well fitted for IoT when you are on low bandwidth. And there is a response code. Here it says 200. 200 means okay, that I accepted your request. There are other response codes. Basically, 400, you know the 404 on websites. This is a 404 sometimes. It's an HTTP code. It means your resource is not existing. Right. So if you made some mistake in the URL, you get 404. There are many other codes. So basically, this is what you need to know, that 200 is good, 400 is bad. 400 means basically you made an error, right? You made a mistake in the URL, you made some mistake. 500 means I made an error as a server. So there is a bug in the server, on the code, right, of the server. 200 means, 100 and 300, therefore information and redirection. So basically your resource is not there, but please go there. All right. Yes. So, okay, so let's go for the MQTT now. So MQTT has different architecture, and it's also based on the central server, actually, which is called the broker. But basically, as Hongduk was saying yesterday, it's not a request response. It's a publish subscribe. So that means some devices like mobile phone, they subscribe on a topic, for example, human presence. It's just a string, actually. You subscribe on that. I will show you that right now. And some of the guys publishing new values on this topic. Tac, 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 tac. Right? And each time a new value is updated on the broker will wake up all the other clients, right? So in this case, the client doesn't have to pull from the broker. It doesn't have to check regularly if there are new values. This is the opposite. This central server will wake you up. So let's try it, right? So on the same tutorial at the end, you have MQTT, because Waziup server is also supporting MQTT, with relatively the same syntax than the HTTP. So let's make a publish. So instead of curl, here I am using mosquito. Right, so maybe some of you know already the mosquito. So I am publishing on same address, right, waziup.io, on a device and on a sensor, a value. Let's try. So here I want to publish. It's like post, but it's called publish. And a value of 3 on one of my device. I remember it was device 2. Sensor is TC1. Value 3. Let's try. Tac.
This is this is what your gateway should do when it receives value from the sensor, right? Exactly.
So the gateway will actually publish to the central server on internet, and then your application will come to that slowly. At the last step, your application will also register on MQTT. So it will subscribe on some topics you are interested in. So basically the topics here, they are sensors. So in our world of the IoT, a topic on MQTT is a sensor. So your application says, I am interested with this sensor. So on one side, you plant the sensor on the ground. On the other side, you register your application on this sensor, and it will get the updates. So let me show you that right now. So here I just published. So first step is to publish, right? So I publish a value. I can also check that it's right. Yes, it's 3 now. But that's like post, right? So nothing new. Yeah, the other way is the subscribe. So let's try to subscribe now. So same thing. So I use, again, Mosquito. It's not Mosquito pub, like publish. It's Mosquito sub, like subscribe. I do like that. I subscribe. All right, now it is subscribed. This command line tool is subscribed on my topic. The topic is all this. So it looks like a URL. It is not a URL. It is called a topic. So a topic is basically keywords separated by slash, and I construct my topic. So we decided to make the topic look like same than the URL on the REST API. So this is the same than here. Right, and also relatively the same than on the dashboard. So now can you check this suspended? I'm not gaining back the control because it is subscribed. So basically, and I will receive there all the new information that will arrive on the platform. So let's open a new window. So this is suspended here, you can see. I open a new window and I will publish something. So, and you can see that it was waken up. So you can imagine that this is your application here, and it has just received the data that was sent on this side, and it was waken up. So here, this is how MQTT is working, basically. You are registering on the topic, and each time a new client publish some values, it will be waken up and you get the value. MQTT has quality of service. Fire and forget, basically your sensor here is sending a piece of data and then doesn't care anymore about it. This is usually the level of quality we use for IoT, because a sensor have a lot of data, and even if some value is lost in the wild, you would just have to wait 10 seconds and you have another one, right? So most of the time we use fire and forget. But there are also a level of quality like deliver at once. So this one, the idea is that your client or your sensor, for example, wants to make sure that his data is arriving at the server side. So it will wait for the acknowledgement for the server, and if nothing comes, it will retry and again, right? So maybe the data at the end will arrive several times on the server side. So it's at least one, maybe more. And there is a third level of quality, is called exactly once. So there's a complex protocol to make sure that the server will get your data only once, right? As a last will, so this is like you doing your testament, right? So what is for a testament? Basically, after you die, you're not here anymore to tell what you want, right? So you write something. So it's called a testament. In the IoT world, we need also last will, for example, after a sensor will die, because they are quite fragile. We said that before. So maybe one of your sensors will die. But what after? So this is the last will. So when you do MQTT, the first thing you do is to connect. So that's what we did here. Now it is in connected mode. So the first thing you do when you start this subscription is connect. And during the connect, you can also provide a last will testament, which mentions what if the sensor disappears. And in this case, for example, you just want to inform everybody, okay, I died. That can be one. Or maybe I died and you should do that, or you should use this value for me, which is the default value. For example, 0 can be a a good default value, so clients can continue working even if your sensor now is dead. So that's the last one. And persistent session, right? This is the opposite, this one, for the persistent session. That means that if this client is super interested by everything that happens with this sensor, maybe at some point this client will go offline, but it is asking the broker, can you keep a log for me of everything that happens? And when I connect back, you give me that backlog of history of the sensor values. So that's the persistent session. So what the difference then? Okay, apart from the protocols, but in terms of performance. So there was some study made on HTTP versus MQTT. One thing is interesting for us is the battery, of course, and the number of messages that you can get. You can see that MQTT has much more throughput. That's basically because MQTT has less ceremony, let's say, than HTTP. You remember what we did before? Yeah, all this ceremony. This is a lot of things that goes on the message, right?
Yes, it's to ensure that we are secure, right?
Yeah, there is a security part. This is TLS, and actually MQTT can also have the same. It's called MQTT-S.
MQTT encrypted, yes, we saw it. Yeah, thank
exactly. But what I'm saying is that the HTTP is a relatively heavy protocol because it has a lot of headers, and the frame of the message is a lot of big. It has different information going on. MQTT is more lightweight, so that explains why you have more message per hour and less battery usage, right? And the battery usage also comes from the fact that with HTTP often you're obliged to poll, so that is ask, is there anything new? No, I come back later. With the MQTT, you register, and then this is inversion of control. You give the control to the server, and the server can wake you up later. So this is also explaining the reduced battery usage in the MQTT. So yeah, it's here. So you can see that at the first connection, not much difference, right? So yeah, very small difference. Here in 3G, it's even worse with the MQTT. Because there is connections, testament, etc. But after that, since MQTT is connected, then the performance is better in terms of battery, 10 times better. So now we'll see that how to embed that into a web application. Okay, so I'll start with a very simple application, which is called HTML JavaScript. So even if you don't know anything about programming, you can do that. So it's really, really simple application, and you can have this application running in the cloud for no money at all, because you can host it on GitHub, actually, which is free. So it has no database, no backend. What we call backend, usually it's an API, also a database, and you don't need to compile it. You just need your browser. So the tutorial is given here. You find it on the website. Web applications. Yeah. So basically what you need is to follow this tutorial. You can do it at home. And there are some examples of web applications. So there are two languages, one is Python and one is JavaScript. And I want you to show that, okay, let's concentrate on the JavaScript side. With the very simple JavaScript, you have a one-page application that you can host on any server and even on GitHub. All right, and let's start with this one. This simple application is a one page of even 20 lines. it's an HTML page. So it starts with HTML. And you have the body here of the application, just one div with one word, and a script. So this is the section of the script. And in the script, we are calling our API, just like we did before, but this time this is JavaScript, right? So we are calling some JavaScript functions. So we are calling the API and getting the sensor data from one device, right? And one sensor, like before, in JavaScript, and then we are displaying that. So there are different examples, one for creating a map, one for creating a graph. So again, the map is only one page, 40 lines. It shows you how to embed a map in your JavaScript. So this is the map here. And the other one is a graph. So let me show you the results. So it is running on something called GitHub Pages, which is just a server for this file. And here the map, right? And you see it was 40 lines, so it's very short, and you can embed that in your website. And this is a position of all our sensors. So we're like in the dashboard that is in your own application, you can embed this one, just copy paste the code. This is a graph here. This is live value, right? And there is a small example with a more complete application. So let's find our sensor, which was my device 2, SM1, device value 15. You remember that? So here we just get the data and display it, right, in JavaScript. So I show you again this here, how to get the data. So here we are calling this. It's a library published by Waziup called waziup.js, and you can call the API and get the data and then display it very simply. So there's even something, if you have a website, you can embed it and show the value of your sensors on your website. So the idea here is to develop your own application. So just one parenthesis is that this website here is good for administrators, for you as developer, for if you have to deploy sensors. So this is very useful. But if you want to deploy an application for your final client, this is not good. It is too complex. It is not enough business oriented. So let's say if you have an application with for the health of cows, for example, with some temperature sensor on the cow, you don't want to expose that to a client. You want to have something simpler on the mobile phone. So you have to develop it actually. So, but the point of using the API, and if you don't know too much the development, you can use this JavaScript embedded in HTML and have a very quick result. All right, so last example is the graph. So let me show you that code. Yeah, not very much longer. It's also 40 lines. And here we are using a chart library and embedding, saying we use also a Waziup API, get the data points and insert them in the graph, and you get the graph. All right. So this is our first web app. So there is another example here in Python. So this one is working with MQTT. So what I showed you with MQTT before, here I use Python instead of the command line. So this example, you can look at it, and it is using a library from MQTT and doing the same that I was doing with the command line. So basically, I publish is here, publish on my topic, publishing a value from my sensor. And actually, this is also something I wanted to show you. It's how to simulate sensor values, because the cloud platform receive values from sensors. And this is done with the gateway. So this is the gateway here that is forwarding the values from my devices. But here we are in confined at home, right? So you might want to simulate your devices because you cannot buy it right now. Let's see how to simulate that. So the idea is to replace the hardware part of our chain. So let's say you don't have this part. You want to just develop a web application working with IoT, but without hardware at the moment. So I included in GitHub a simulator. So it is here. It's called Sensor Sim. Oops. So you can open this simulator. Sorry. So it's on GitHub / Waziup. And you try to find one. It's called Sensor Sim. And this is a sensor simulator in JavaScript. So there is some instructions here to use it. So you have to git clone and then go with npm start. And this will simulate your sensor basically. And then you will be able to start to develop your web application. So let's try it. So actually, you find some folder. You type the git clone. Here I have it. I go in, and I just type npm start, like it is mentioned here, and it will push. Oh, something is wrong. Yeah, sorry. npm install first. I have to correct the README file. Done. Okay, and it starts sending data. This is what it sends every second. So it is sending actually quite a lot of data. Let's see what is sending. So it's a very simple application with only two files. Here is the JavaScript example how to send the data to the Waziup platform. Again, same system than before. We use here HTTP post. So we could use MQTT. Here we use HTTP. We send something on the device, some random values every second, and on which device. So it is included in this other file. It's called my device too. So always the same device. So I started. npm start. So npm is the package manager for JavaScript, right? For Node, actually, exactly. If you have heard about it, it's called Node.js. It's a flavor of JavaScript. So it is now sending the data, and same as before. So we are simulating basically a sensor. Yeah, it's called C1, sending random values. So, all right, it is here, and I can see that it's going up and down and up and down because it's a random actually. All right, so now last value is 0. If I update, I should see another one, 7. All right. Okay, this is how you simulate some device. So once you have your simulator, you can start creating your web app. This dashboard here is also a web app. It's made in React.js. So React.js is actually much more complex. And for that, in the slides that I will give to you, I include some a link to some lessons that I find that are quite good on Code Academy. So if you want to start learning React, you can do that. So they are giving lessons, and basically exercise, interactive exercise that you can give your code online and it's checked automatically. It's very well made. So if you want to learn React, I think you could start with that. React basically use JSX, which is a syntax to create HTML pages, right? And it is also a functional language. You can say it's a functional framework because it wants to react when the user at the user inputs. It has some mechanism to react to the user inputs. All right. So if you want to start with React.js, one thing you can do is to start from this dashboard here that we provide open source. So why not, right? So you can do it also quite easily, extracting it from GitHub. So it is provided. It's part of Wazicloud. And it's here, it's called dashboard. So it has its own repository, right? And there is instructions how to run it. So basically, we download this repository here and we type yarn start. And yarn is like NPM. It's also a JavaScript package manager. And you can start yarn start, but it will not have any database, so nothing will be displayed. So the best is to do the yarn start with some preliminaries here. We mentioned that we want to get the data from the online cloud, right? So let's do that. So let me show you how it is done. So I have already, of course, downloaded this dashboard made in React.js, right? It is here in this folder. And now I'll do the yarn start. Not the small one, the big one. So I yarn start my React.js application, providing some environment variables to tell it where it should take the data. So it will take the data from the Waziup API. Start. So React.js is, there is two parts. There is a client and a server. So it's more complex than the basic JavaScript application embedded in HTML. And the server will send the client to your browser. So it will send a bunch of code to your browser with also HTML. And here you see I am running now my dashboard, my React.js application on localhost. So it is running now locally. And basically it's the same, right? Because the data is coming from the cloud, so it's no different. All right. So I think we've finished our overview. So there will be more lessons on more specific topics, probably on, for example, on data analytics in the next weeks. So yeah, stay tuned. We'll organize that. Also, it's a good, strange but good period to learn, right? Some new things. So in this lesson, I tried to show you some things you can do at home, which is playing with the APIs and playing with the small web applications. I hope it was interesting, and I'm happy to hear if there is any questions. Maybe I should unmute. Yeah.
Hello.
Yeah.
I have a question.
Yeah.
I was wondering, where during your presentation did you set up the MQTT broker?
Yeah, good question.
And what will the setup look like? And secondly, what is the rule of thumb when selecting the QoS flags for the MQTT?
What is the role of the QoS flag?
What is the rule of thumb? What is the criteria for selecting those three QoS
Yeah.
flags?
Okay, so good question. So the MQTT server, where is it? So I used the MQTT server, right? I didn't start any, so it's because it's located in the cloud. So let me, this cloud platform here, this is a dashboard, but there is also something we call a backend. It's located on Amazon, basically. So we deployed actually Mosquito server on Amazon. So we have a VM there. Here it is. So I manage it actually. So we have a VM containing the number of services, and one is MQTT. So this one is actually Mosquito server, right? So it's permanently running. You can use it at any time. And if you are developing a web application, you can query it using the API I was giving before and the tutorial you can find online. Yeah, that's the idea. But at home, you can also, if you want to be completely autonomous, you can also run your own, right? And you just download and install Mosquito, start it, right? Now it's listening. So I could retry the same exercise I did before, but using my local instead.
Okay.
Yeah. So for example, this publish here, it was pointed on the cloud, but now I want to point it on localhosts. Yeah, it's working. So you see it moved. So this Mosquito server here is running a server, and it received something apparently. So it was moving, right? So I could also, yeah, publish, but I could also subscribe. Okay, I let you try it. It's quite funny. So the idea, you start your server, then you start a publish, and you start a subscribe, and you see them chatting. So it's easy to make some chat applications, like Kongduk was saying yesterday. Yeah, another question. So you had another question, right? Can you remember?
Yes, I was asking, is there any criteria, or rather, what is the rule of thumb when selecting the QoS flags 0, 1, 2, which is preferred?
I think by default it's fire and forget. I'm not sure if I do Mosquito pub, which one is used. So in the help, then will tell me QoS. You can specify the QoS here. I didn't use. I think by default is 0. Rule of thumb, you have to ask yourself, is my data super important or not? I am willing to trade some bandwidth for security. For sensors, I can tell you that sensors data is not so valuable because you have many of them. So even if some data is lost, maybe after some seconds or some minutes, you have another one. So it's not worth spending battery on that. But if you have an application which is more critical, I don't know, you have elevators, or you are running a plane, or you want to be exactly sure that the data was received. So you can activate a better quality of service.
Okay, thank you, Doctor.
Thanks.
Hi, Corentin, can you hear me?
Hi. Yeah, I can hear you.
I would like, well, first of all, thanks a lot to you at Conduct Fund for this webinar.
Thanks.
What do you
Excuse
think,
me?
in your experience,
Just,
which
can you,
auxiliary...
hello?
Yeah, who is speaking?
Yes, I'm speaking. Just for my understanding.
Sorry, Matthias was speaking, right? Maybe not very loud.
Yes.
Hello, can you hear me?
I would
Let's hear Matthias' question, and then we can hear Mustafa.
Okay, okay.
I would like to know which device is better for a normal gateway. if you think that a Raspberry Pi 3 Plus or 4, or the 0W, which is better for as a device.
So I didn't understand your question. Could you repeat?
In your experience, which device you think is better for a gateway? Raspberry Pi 3, 3 Plus, 4, 0W?
For a gateway, right? Or for what application?
As a gateway, yes.
For making the gateway. All right, so we have three, I'm not exactly sure, let me look, but it's, this is 3B plus, I think. And we are looking at the 4 actually. Okay, it depends also on the kind of application you want to make. I'm telling you some not so secret. We are also working on a new gateway, and the next version will be called Edge Gateway. That means that in this gateway you will be able to host your applications. So the basic schema now is that the application goes in the cloud. So in this here you put the application here in the cloud. So, but some places and often in Africa, we work a lot in Africa, and the internet does not go in the countryside. So or it's very slow. So we want to work without internet. So that's what we want to have powerful gateway. And you put your application in this gateway, and then you connect your mobile phone to the gateway with a hotspot, basically. And then you get this application on your mobile phone without internet. So that means we need a powerful gateway. In this case, we will look at the new Raspberry Pi 4 that is coming up. Another requirement is that you need, yeah, the software is not that big actually, so you need 2 giga, but I think most of the SD card now, they are 16 giga, so it's not really a problem. So I think a 3B plus is okay.
Okay, thanks.
Thanks. There was a question for Mustafa.
Yes, just about the whole path, beginning from connecting data to the server, to the cloud. So if my understanding is good, so the sensor has the data, it encapsulates it on a LoRa frame or frame, which is sent to the gateway, and then the gateway is just forwarding the data. There is no intelligence inside the gateway, right?
Yeah, at the moment, but as I'm telling, we are going.
Yeah, I heard about the next generation gateway. Thank you.
Right. Yeah. Any other question?
Yes. Hello, sir. Thank you. Hello.
Yeah.
Can you hear me?
Yeah, I can hear you. Go ahead.
Yeah. Thank you for your nice presentation. I have 2 questions. The first one is you give us a simulator for the web application. Do you have a simulation for the hardware part, like for the Arduino, like for the sensor? How when you want to configure it to program the microcontroller? Do you have a simulator for Linux? And
that's a good question. Actually, I don't know. I think what you are asking if I have a simulator for running a code, right? Arduino code.
Yeah.
I don't know actually. Maybe you can find on the internet. It's a good question. So here, it's, this program here is compiled. It's cross-compiled actually. It's not for my processor on my laptop. It's for the microcontroller on the Wazidev. I don't know about a simulator for Arduino processor. So this one is a Pro Arduino Pro. And I have to look, but it's a good question. That would be
I don't know, but maybe the mean will be to have some people sharing their boards if we can flash on the air or flash via internet. You have some guys putting their Arduino shared others. If I don't know if it's possible, because similar to working your code, it's cross-compiled for Arduino, so it should be flashed on an Arduino. I don't know.
Yeah. But probably there are some simulators that you can find. It's a good question. I know there are some websites. Yeah, you can find.
It's called an emulator, right?
Emulator.
Huh? Emulator, yeah, emulator.
Emulator, not C.
Yeah. Like just to test what if you do is correct before you deploy it.
Yeah.
Yeah.
I think so you can find. Yeah. Good question. So that can be useful. Yeah. so you can even without hardware continue working on your project. Another question?
Yeah. The second question is like you give an example where you use machine learning algorithm.
Yeah.
Yeah. I was wondering, like, if you want to deploy like you want to train your model and to use it to use it for predicting in your web application.
Yeah.
Are you using the same cloud, like sorry, or you need to turn in another cloud to do the prediction in the web app? How it works?
All right. So basically, the way we did it is that we are using Waziup for collecting the data and managing the sensor, managing the gateways. It is not making the prediction. So the idea that you download your data, so there is a button here, download data. You can do that with the API. I think we saw it several times. You download all the data, right? And you put that in a JSON file or a CSV file. And then you use some engine for making the prediction. So I was talking about this competition. So I've put all the results of the competition on GitHub. So yeah, this is a competition, and let's try to find GitHub. So if you go on the Waziup GitHub, so there is a repository called Soil Moisture ML, like machine learning. And here there is all the data and the result and the code. So the winners are here. And the solutions provided by the 5 winners are also provided, so you can analyze it. And I will make a tutorial maybe to make it more easy to follow. But this is one competitor solution here in Python.
Yeah.
So yeah, it's some Python code. Then it is opening the library XGBoost and opening the data, then training the engine. So first preparing the data, because the data has to be put in a very specific shape for the machine learning engine. Then you feed your engine and you train your model. And then you extract some prediction from that model and you win the competition. So this is the solution. Yeah, so the data is here in some specific format. And at the end, you get the predictions and you submit the file. This is the submission. So if you're interested, you can look at this example. It's a good example how to make machine learning with IoT. So basically, you want to predict what happened after.
Yeah, but if I understand, like you first gather the data and then do your analysis and prediction after. It's not on real time, is it that?
No, it's not real time. It's offline.
Okay.
It's
yeah.
offline. Online is more complex, I think, at the moment. Well, there. But the idea with IoT. It's also like that. So because it's not easy to find a good model and to use it. So my opinion is better to do it offline. So you use data from past month and you train your model with that. on your laptop.
No, I wanted like to say, for example, sometimes like you can train your model, like this model, you already trained it, but you can use it for future predictions. Like you already got the model, you don't need to train it again.
Yeah.
But like, can you use it in the web app to just do the prediction, not to train again, but to just do the prediction directly in real time in the web app?
Yeah, that's a very good, very good point. So, yeah, the idea that you can train your model one, and then you take the model. A model is a big file, actually, a big array of parameters, and then you use on your web application, you use only the last part, which is the get prediction. So, model is trained. You give the model here, and you extract the prediction for new data. Of course, I'm not sure it will work on the long term because you have to retrain models. There is some drifting of the model because the environment might change a little bit. So the soil might be a bit different. The plant is growing also. So sometimes you need to retrain your model. It will not always work in any point in the future.
Yeah. Thank you again.
Okay, so if there is no other question, I think we can finish this webinar. Thank you for being with us. Wish you a very good afternoon. So there will be French session in 1 hour and a half from now. So yeah, thank you very much.
Thank you. Bye bye.
Thank you. Bye.
Thank you.